Right now, you are watching a video. Maybe you're eating lunch, maybe walking through a park. The most ordinary minute of an ordinary day. One planet, 600 million kilometers away, made this minute possible. It has been catching rocks meant for you for billions of years. In July 1994, humans finally watched it work. A comet slammed into it with 600 times the power of every nuclear weapon on Earth put together. And that rescue is the smaller half of this story. Jupiter outweighs every other planet in the solar system combined, 2.5 times over. 318 Earths worth of mass. You could pour 1,300 Earths inside it and still have room. A full spin takes under 10 hours, a solar system record. And its gravity reaches everywhere. The Sun itself wobbles around a point above its own surface because Jupiter drags it in circles. Keep that wobble in mind. In March 1993, at Palomar Observatory in California, Carolyn Shoemaker, her husband Eugene, and David Levy photographed something nobody had ever seen. A comet broken into 21 pieces, strung out like pearls. Jupiter's gravity had ripped it apart on an earlier pass, and the fragments were coming back. Between July 16th and July 22nd, 1994, they slammed into Jupiter at 60 kilometers per second. Fragment G alone released 6 million megatons of energy. Telescopes across Earth watched fireballs rise 3,000 kilometers above the clouds. The dark scars stayed visible for months. Some of them were larger than Earth. This was the first planetary collision humans ever witnessed. That same year, planetary scientist George Wetherill published a calculation. He simulated solar systems like ours, with Jupiter removed. In those systems, long-period comets crossed Earth's orbit roughly 1,000 times more often. That means a civilization-ending impact every 100,000 years, instead of every 100 million. Jupiter's gravity ejects those comets entirely, or swallows them itself. Astronomers started calling it our shield. And the hits keep coming. In July 2009, amateur astronomer Anthony Wesley aimed his backyard telescope at Jupiter from rural Australia and found a fresh black scar the size of the Pacific Ocean. Nobody had seen the object coming. In 2010, 2012, 2016, and 2019, amateurs filmed bright impact flashes. Jupiter absorbs a serious hit every year or two. Earth takes one every few centuries. Jupiter also keeps order across the whole system. Between Mars and Jupiter circle over 1 million sizable asteroids. Map their orbits and you find clean, empty lanes, the Kirkwood gaps, first spotted in 1866. Any rock drifting into those lanes gets rhythmic gravitational kicks from Jupiter until it leaves, sometimes headed toward the inner planets. And along Jupiter's own path travel the Trojans, 2 swarms of captured asteroids, over 10,000 cataloged, one crowd running ahead of the planet, one trailing behind. NASA launched the Lucy probe toward them in 2021 because they still hold leftover material from the solar system's construction. So the story seems obvious. Big planet guards small planet. Except in 2008, astronomers Jonathan Horner and Barry Jones at the Open University in England ran the numbers again. The shield idea cracked. Yes, Jupiter deflects long-period comets. It also stirs up the asteroid belt, and the belt sits far closer to us than any comet. Their simulations showed something uncomfortable. A planet with Saturn's mass, parked in Jupiter's orbit, would throw more rocks at Earth than Jupiter does, and more than an empty orbit would. Jupiter blocks comets while occasionally flicking asteroids our way. The rock that ended the dinosaurs 66 million years ago probably came from that same belt. Our particular Jupiter happens to sit near the safest possible mass. That part comes down to luck. But Jupiter's real gift came earlier, before Earth had oceans. Earth formed inside the frost line, the distance from the Sun where water ice can survive. Our planet should have formed bone dry. Yet water covers 70% of its surface. Measure the hydrogen isotopes in our oceans, and they match carbonaceous chondrites, meteorites born beyond the asteroid belt. Something threw that wet material inward. In 2011, planetary scientist Kevin Walsh proposed the Grand Tack model. Young Jupiter spiraled toward the Sun, all the way into where Mars orbits today. Then Saturn grew, caught up, and locked into resonance with it. Both giants reversed course and migrated back out. That maneuver scattered icy bodies toward Earth, delivering the water sitting in your body right now. It also stripped building material from Mars's neighborhood, which explains why Mars weighs a tenth of what Earth does. And it may have done something even bigger. In 2015, Konstantin Batygin and Gregory Laughlin argued that this early migration wrecked a first generation of inner planets, a set of super-Earths, and swept their debris into the Sun. Mercury, Venus, Earth, and Mars grew from the rubble left behind. If they're right, Jupiter demolished the original inner solar system, and we live in the replacement. You can test this against other stars. In 1995, Michel Mayor and Didier Queloz found the first planet orbiting a Sun-like star. Since then, the catalog has passed 5,000 exoplanets. Remember the Sun's wobble? Wobbles like that revealed many of them, and most of those systems look nothing like ours. Astronomers keep finding hot Jupiters, gas giants orbiting closer to their star than Mercury orbits ours. A giant migrating that deep scatters every rocky world in its path into the star or out into interstellar space. Other systems come packed with super-Earths on tight orbits, exactly the arrangement Batygin and Laughlin believe Jupiter destroyed here. A giant on a wide, calm, nearly circular orbit like Jupiter's shows up around roughly 1 in 10 Sun-like stars. Ours went in, turned around, and settled down. Since 2016, the Juno spacecraft has been circling Jupiter, mapping its gravity. The data revealed a strange, dilute core, heavy elements smeared halfway through the planet. One explanation, a head-on collision with a planetary embryo 10 times the mass of Earth, swallowed whole. Even Jupiter's insides record a violent history. So could we live without it? Delete Jupiter tonight, and tomorrow feels completely ordinary. The comet flux creeps upward over thousands of years. The asteroid belt slowly drifts out of shape. Give it 1,000,000 years and asteroid orbits begin to scramble. The real answer sits 4.5 billion years back. No Jupiter means no grand tack. Probably no water delivery. Possibly a row of super-Earths where Earth should be. Maybe no Earth at all. The planet we can't live without has no ground to stand on, and no human will ever walk on it. It finished its most important work before anything was alive to say thank you.